Hello all, today we're going to be looking at implicit differentiation. And what implicit differentiation really is say we had an equation like this one. We can see that it is implicit because the x's and y's are both on the same side. It's not like 4x plus 2 equals y, for example. And because of this, we need to differentiate in a different way to what we usually would do, because we have to differentiate with y in there. So, what we're going to do is we're going to establish some core rules before we begin about implicit differentiation, and then we're just going to go through and we're going to differentiate every single term. And this, again, is going to help us find the derivative, the dy over dx. So, let's start off with the core fundamental points. And we need to know that y prime is going to be equal to dy over dx. And this is based on the chain rule. And if you get an understanding of the chain rule, you'd understand why this would happen. But again, what we're doing is we're differentiating with respect to x. So that's why y prime is going to be dy over dx. And x prime is also going to be equal to 1. Which is our next major point. So when we differentiate x prime, always to 1, because we're doing it with respect to x. And I'll come back down and show you a few other key points in a minute, but let's just get started by differentiating our first term. So what we're going to use is a power rule, because this one's a nice and easy term to begin with. So what we do is we bring our 2, which is the exponent, down to our coefficient and multiply it by our coefficient. Again, just the power rule. So we have 2x, and then we subtract 1 from the exponent. 2 take 1 is 1, so we're just left with 2x as being our first term differentiated. Now what we need to do is we need to apply the product rule to our second term. And the product rule, you may remember it, I'll just write it down here, is if we have the f of x gx, which is essentially what we have here with our xy term, then it will equal the f prime of x gx plus g prime of x fx. Okay, so now that we've got that down, we just need to apply it to our term. So, first off, with our x term, we're finding the derivative of x. So, we're differentiating x and we get 1 because of it, because f prime equals 1. And then what we do is we just multiply it by the next term as we usually would, just based on our product rule here. So we get 1y. Now what we do is we find the derivative of our second term y, and again, y prime, when we differentiate it, is dy over dx. So that's plus dy over dx. And then we multiply that by our normal first term, which is just going to be x. So again, that's just a product rule in action there. And then lastly, we just need to differentiate our last term, and again, we use the power rule to be able to do this. So we bring the 2 down to our coefficient y, and coefficient of y, and we get 2y. And because it's 2 take 1, what we get is 1 in the end. So we just have y to the power of 1. And again, because we're taking y prime, we need to be able to multiply it by dy over dx, because we're differentiating with respect to x. So now what we do is we differentiate our constant on the end there, and the derivative of a constant is always 0. So that's nice and simple there. Again, just another rule to keep in mind. So what we now do is we now simply gather all our like terms with dy and dx, all our terms that have our dy dx in it, and we want them on one side of the equation. So what we can do to do this is we can just get rid of the terms that don't have dy dx in them, and we can move them to the right hand side of the equation. Now we get dy dx times x plus 2y times dy over dx. Again, we're just leaving them on the left hand side, so they remain unchanged. But then we're moving our non-dy dx terms to the right hand side, so we need to inverse their operation. And again, 1y just simplifies down to y. Okay, so now that we've done this, we'll put the dy dx as being our common term, and then we just fill in the gaps. So we have x and then plus 2y. And lastly, what we're going to need to do is just use a fundamental concept of algebra to be able to move this to the other side. And again, because this is in the numerator on the left-hand side, it'll be in the denominator on the right-hand side. So, our derivative of our implicit equation, x squared plus xy plus y squared equals 18, will be equal to negative 2x take y over x plus 2y. And what we found here is we basically just found how we can turn an equation where y isn't the subject into our final derivative form. And because a derivative of a constant is always going to be 0, you can pretty much solve any x squared plus xy plus y squared term down to this, because again, you can just take any constant on the end, whether it be 72 or 54, and it will always go down to 0. So there's just a look at implicit differentiation. I hope you understand it, and when you develop the chain rule you understand why we use dy over dx a bit more, but again, this is just a fundamental concept, and I hope you enjoyed this video. Any comments, just leave them below. Thanks.